So now in this video, we're going to look at using the JFET and channel JFET. This is J310 as a current source or a current sink. So the current flowing through here in series is going to be the same throughout the series circuit there. The gate is just looking at voltage. So we got the drain up there, the source there, and then it goes through the resistor. The gate's looking at the voltage. And we're going to fill that gap with the meter. So ultimately the transistor sets the current, but this resistor from source to ground right there adjusts the amount of current. So it's variable with the transistor and even other number of other factors. But in any case, the way we have this set up, as we change the voltage, current should be the same. After we take those current measurements, we're going to slide that jumper up there and slide the LED down there so that it is in series. Long lead anode positive, short lead cathode more negative. And we're going to find that without changing anything else, we should have the same current within that voltage range as we had without the LED with no load at all. So now we got the meter. You can see the power supply voltage, 8 volts. We set it to measure milliamps of current. That's important. You got it set to measure more current than you're going to measure. Red probe stays there. So this isn't going to be a detailed current measuring video. We're going to make this quick. So we're going to measure their no load, and that's what I was getting earlier right there. That's what I was expecting. So that's at 8 volts. You can see that the current isn't the same on the power supply. This one is less accurate. So you can get an idea of how much current's going through. Pretty good idea, but it's not as accurate. So it's better to take current measurements with the meter if you need precision. So there we go. We raised the voltage quite a bit, 4 volts, and we got basically the same current. It, shifts a bit, but that was hardly any shift for how much voltage change we had. So it wasn't a terribly dramatic voltage change, but it was significant voltage change with just a very small amount of current change according to the meter. So I moved the jumper up one spot, as you can see there, and now I'm going to take the blue LED right there. So that drops about 3 volts, and so that kind of limits the lower end of our voltage range and increases the upper limit where we're going to hold current really steady. So I set the power supply back to 8 volts right there, and there you can see, so this is a spec shy. I think 8 was just a spec lower in voltage for holding as steady right there. There you can see 9 went up a little bit. So let's just go right to 12 and take that measurement. That's the main thing. We're getting pretty much the same amount of current, just slightly varying with fairly dramatic changes. So it's an okay current source. There are better current sources, but a lot of times, like within integrated circuits or something, you may see a JFET being used as a current source, and it helps you understand what's going on inside the integrated circuit or whatnot. But also, if you really want to, if you have them laying around, you may set a current, about 5 milliamps or whatever. You go up in the resistance between the gate and source, it lets less current through, even as voltage changes. And a lower value, it lets more current through, up to that IDSS, which we did in the last video. That's the maximum current a particular JFET will use, which is highly variable. So I mentioned that in the last video. These are all topics. If you really are interested in it, you really got to read a lot. There's a lot of material out there to cover these. I'm just giving you a brief preview and demonstration. So hope you enjoy. Make sure you check out one of the other videos I posted screen, and check out the links down below. I set the voltage to 5 volts because I'm used to it being 5 volts and a maximum of 20 milliamps of current. So I try to set that back whenever I change it. So thanks for watching. See you in the next one.